membrane preparation and characterization. There are two receptors or synaptosomes that can be used for RBA for PSP. The commercially available porcine brain homogenate being produced by Sigma Aldrich for American Radio-Labeled Chemicals Incorporated, or ARC, and the rat brain homogenate, which can be prepared in the laboratory. For this learning module, the preparation and characterization of rat brain homogenate will be demonstrated. A. Preparation of rat brain homogenate. For membrane preparation, you'll need the following reagents, materials, and equipment. 1. MOPS choline chloride PMSF buffer at pH 7.4. Prepare the buffer following the standard procedure in handling chemicals and applying good laboratory practices. 2. Ice. 3. Spatula, petri dish, scalpel, pointed forceps, and an ice bucket. 4. Beakers, centrifuge tubes, and cryovials. 5. Glass or Teflon homogenizer. 6. Single and repeater pipetors. Rat membrane extraction follows the procedure that will be shown. 1. Remove medulla and cerebellum from each brain using pointed forceps and discard. Carefully place the brain in a small amount of ice-cold buffer. The level of the buffer should be enough to cover the brains, and make sure that the brains will not be disrupted. Place container on ice. 2. Place one brain in 12.5 milliliters of MOPS choline chloride PMSF buffer at pH 7.4 in a glass or Teflon homogenizer. Note that a brain has two cerebral cortices. If the available glass homogenizer tube is 30 milliliters, place two brains in 25 milliliters of buffer. Then, homogenize at 70% full speed, equivalent to 385 RPM, with at least 10 up and down strokes. If necessary, increase the number of strokes to ensure that there will be no visible chunks remaining in the homogenate. Make sure that the tube is always on ice during the procedure. Pour the homogenized tissue into a 250 ml beaker on ice and repeat procedure with remaining cortices. 3. Transfer pooled homogenized tissue to centrifuge tubes. Balance the tubes pairwise and centrifuge at 20,000 relative centrifugal force for 15 minutes at 4 degrees Celsius. 4. Quickly aspirate or pour off supernatant. Resuspend pellets in ice-cold MOPS choline chloride PMSF buffer in the centrifuge tubes. Use an adequate amount, approximately 5 milliliters, not exceeding the total amount that you need. That is 200 milliliters for 20 cortices. You can use clean glass stirring rod to break up the pellet. 5. Pool resuspended membrane preparation in a small beaker. Rinse the centrifuge tubes with a small amount of ice-cold buffer to transfer all membrane preparation. Bring the total volume to 200 milliliters total. Make that the procedure will be performed on ice. 6. Polytron at 70% full speed for 20 seconds. Again, keep the beaker on ice. 7. Aliquote 2 milliliters per tube into cryovials. Aliquote of 1 milliliter may be done if preferred. Note to keep the preparation well mixed while aliquoting to ensure equal allocation of protein receptors to each cryogenic vial. Mix prior to each aliquot and keep cryotubes on ice. 8. Freeze and store at -80 degrees Celsius. This preparation is stable for at least 6 months. Label the tubes and the containers properly. B. Protein assay. Protein assay is a biochemical assay to determine the total amount of protein, which includes the voltage-gated sodium channels present in a membrane preparation. Any protein assay kit may be used for this purpose. Any protein assay kit may be used, but for this learning module, we use the Pierce Micro BCA Protein Assay Reagents, number 23225, which is in tube format. The total protein concentration is exhibited by a color change of the sample solution from green to purple in proportion to protein concentration, which can then be measured using colorimetric techniques. For this assay, you'll need the following reagents, materials, and equipment. 1. Bisanconic acid, or BCA, labeled as reagent A. 2. Copper sulfate pentahydrate, labeled as reagent B. 3. Bovine serum albumin, or BSA. 4. Prepared rat membrane. 5. MOPS, choline chloride, PMSF buffer at pH 7.4. Prepare the buffer following the standard procedure in handling chemicals and applying good laboratory practice. 6. Micropipetors, microcentrifuge tubes, 5 ml test tubes with caps. 7. Ice, distilled water, oven, test tube holder, and vortex mixer. 8. Cuvettes, UV spectrophotometer. The protein assay follows the procedure in triplicates that will be shown. 1. Prepare a dilution scheme for the protein calibration standard with a linear range of 10 to 500 microgram per milliliter using bovine serum albumin. The volume needed is 120 microliters, each standard concentration. 2. For the rat membrane with unknown concentrations, it may be necessary to prepare a dilution scheme to ensure the concentration is within the linear range of 10 to 500-fold dilution. Researchers must determine their own dilution schemes based on their estimation of the concentration of each unknown sample. The volume needed is 120 microliters each unknown sample. 3. Prepare the required amount of BCA working reagent needed. The BCA working reagent is prepared by mixing 50 parts of reagent A with 1 part of reagent B. Mix the BCA working reagent until it is light green in color. Mix until the BCA working reagent is a uniform light green color. The final volume of the BCA working reagent will depend on how many blanks, BSA protein standard solutions, and unknown samples to be assayed. 4. Add 2 milliliters of the BCA working reagent to 0.1 ml of each BSA protein standard, blank, and unknown samples. Seal test tubes with caps and vortex gently for thorough mixing. The total liquid volume in the test tube is 2.1 milliliters. 5. All solutions prepared will be incubated using the following incubation parameters: 60 degrees Celsius for for 15 minutes, or 37 degrees Celsius for 30 minutes, or 25 degrees Celsius or room temperature for 2 hours to overnight. The use of an oven is recommended to ensure constant temperature during incubation. 6. Allow the tubes to cool to room temperature. 7. Transfer the reaction solutions into a cuvette. Measure the absorbance of the solution at 562 nanometers. Color development continues slowly after cooling to room temperature, but no significant error is seen if all the tubes are red within 10 minutes of each other. 8. Create an assay table as needed and a standard curve based on either the BSA protein standard concentration or on the amount of protein present in the BSA protein standard. Determine protein concentration by comparison of the absorbance of the unknown samples to the standard curve prepared using the BSA protein standard. 9. Using the concentration of the rat membrane, determine the dilution to be used in RBA that will enable you to have 1 milligram per milliliter working solution of the rat membrane.